Okay. Hello, and this is my How to Properly Help a Friend in Algebra 2 project. Today we're going to be talking about parabolas. So, the forms that parabolas come in that I'll be talking about today are standard form and vertex form. We are going to talk about standard form first. This is the formula for standard form. Y equals ax squared plus bx plus c. But right now we're just going to focus on this first part, y equals ax squared. This right here is the parabola. This is what makes a parabola. Y equals x squared is just the basic parabola. But we're just going to have a there. A could be anything. It could be 1, it could be a million. You don't know. So this is what a parabola is. Y equals x squared. This is a parabola. This is your standard textbook parabola. Now what's the difference between this parabola and this parabola? Of course, as you can tell, this one opens up and this one opens down. This is because for this equation, it's y equals negative x squared, meaning the a is -1. So, if a is greater than 0, it opens upwards. If a is less than 0, it opens downwards. So -1 is less than 0, so it's going to open downwards. Now, what's the difference between these two parabolas? If you could tell, the difference is this one is more narrow than this one. So, as you can see here, y equals 1/2 x squared, and this one is y equals 2x squared. As you can see, the difference in the a's are that this one is lesser than this one. In consequence, this one stretches and this one narrows. This is because for the standard way to draw a parabola, it adds which x's that the parabola's points are going to be on. So if it multiplies by this, then it's going to be wider, and this one's going to be more narrow. Just know the vocabulary for this is stretches and narrows. Alright? Next, we are going to look at this. Very sorry, I went up one there. We're going to be looking at the plus c now, and we're going to keep this for later. So, this is y equals x squared, the basic textbook parabola. But this, as you can tell, it does not start at 0 like this basic parabola does. This is because this is the standard parabola plus 1. Now this is going to be the y placement of the parabola. Now that we got that covered, let's review for just a little bit. Now, we've covered this, and this is the y placement. But you may be wondering, what would this be? Well, the b of x actually helps with the axis of symmetry. A and b both work together, a being before x squared and b what we're covering now, both work together to get you the axis of symmetry. The axis of symmetry is a midway point in the parabola that acts as a mirror. As you can see here, this is the axis of symmetry. It lands right in the middle of the parabola. Here I found this great image to tell you what the axis of symmetry is and how to find it. So, let's say it's y equals x squared plus 12x plus 32. So that'd be A, B, and C. Now, here we are with the first part of the formula before they put in their numbers. So, with that being said, the axis of symmetry equation would be x equals negative b over 2a, which would equal negative 12 over 2. which would be -6, meaning the axis of symmetry in this equation would be -6. And here's just an example of what the, if S meant symmetry, what the equation would look like. Now, let's do a little review once again. This is y equals x squared. A would bring you the whether it opens up or down, narrows or stretches, and this would be the y placement, and this would help with axis of symmetry. So, with that being said, you may be wondering, how do you find the y-intercept? Well, the best way would be to set the x as 0. This would mean making all the x's zeros. So y equals 40 squared, which would be 0, plus 6 times 0 squared, times 0, I'm sorry, plus 9. So the y-intercept would be 9. And as you can see here, we are correct, because there is the y-intercept right there when I plug this into Desmos. Now let's do some standard form practice problems. I'm so sorry, I did not put the transition there, so I guess you could just find the graph, because it tells you the y-intercepts. Even though it would be pretty easy to find it, I just gave it to you right there, so that's my fault entirely. But at least I have the graphs there for you. If you'd like, you would pause the video and, sketch these for yourself. And here are the answers. So here we are, the y-intercept, the x squared plus 2x, and yeah. Now, remember this photo? Here we covered the standard form, now we're moving on to the vertex form. This is the equation for the vertex form. In my opinion, I very much prefer the vertex form over the standard form because it is so much easier to understand for me. So, let's remove that minus h plus k, and that would get you ax squared. Does that seem familiar? Well, that's because it is. Let me give you a hint. This is the vertex form with it. This is standard form, also with its additions. And this is without it. Same exact thing, but just with different additions. Alright, now that we got that covered, let's move on to building it up from there. Since we know that from previous knowledge, we already covered a, it's the same exact thing, ax squared, we've covered that, it's the basic textbook parabola. Now let's talk about these additions. So plus k, let's see here, does this also seem familiar? That's because it is. This is y equals ax squared, that would be the basic textbook parabola, y equals ax squared plus 3, it would be parabola, just moved up. The plus k is the y placement. It's just like the plus c. It's the same exact thing as c in standard form. These two are the same exact thing. They both tell the y placement. Alright, now let's see what we got here. We got a, which tells if you stretch or narrow, and it tells us up or down. It's the same exact thing as standard form. It tells the y placement, also the same thing as standard form. Now, you may be wondering, what's h now? Well, it's the x placement. Very easy to understand here. But please do keep in mind that this says negative right here. A lot of people mess this up, and it's basically where it tells you the opposite. So if you had a minus 8 there, that would be a plus 8 on a number line. If it's a plus 8, then it would be a negative 8 on a number line. So, with that being said, how do you find the y-intercept? Well, the best way is to set x as 0, just like standard form. And that's also how to find the vertex. Because let's say a equals 1 at all times, just for the sake of having this be clear for right now. This does not well, just for right now. Okay, you know what I mean. Say a equals 1 all times. So, y equals x minus 6 squared plus 7. Then, the vertex would be 6, 7. And here we have y equals x plus 8 squared plus 9. Notice this has the plus there, so that would be negative 8 for the x and 9. This goes hand in hand with the axis of symmetry. As you can see, we have this equation here, it's coming down here. We have y equals x plus 8 squared plus 9, so the vertex would be at the x part of, the axis of symmetry would be at the x part of the vertex. So the axis of symmetry would be negative 8. Alright, here's some practice problems. It appears I did not put a transition on these, so there are the answers, but if you can, if you'd like, you could check my work. You can just undo it, and if you want, you could make your own problem using the formats that I showed you. Here's some additional resources that I have linked in this PowerPoint. If you would like to find these, I will send it to you. And yeah. Thank you for watching. I will see you the next time I have to make a video project. Goodbye.